Modern enterprise networks have reached a breaking point in density and scale. The traditional approach to monitoring these environments relies on pinging individual components, and under the weight of current traffic volumes, that reactive model is failing. Legacy tools are built to look at isolated endpoints and individual data packets. Because they focus exclusively on those single points, they are structurally blind to the systemic connections between them. To bridge that gap, PTCP and TNQG technology maps every telemetry point as a coordinate within a multidimensional geometric mesh. By treating the network as a continuous shape rather than a list of parts, a change in one service's latency or trust level physically deforms the entire manifold, making invisible dependencies visible. This framework provides a productizable control plane layer for enterprise server racks and cloud instances. It focuses on the immediate telemetry needed for compressed routing and security scoring. By continuously tracking the physical shape of this manifold, the system can instantly detect when a route starts to twist and drop a strict quarantine box around the failure before it has the chance to cascade. But integrating a completely new mathematical framework into your stack requires real engineering effort. As a leader, you have to look at the friction of adoption and decide if the operational payoff is worth it. This decision tree maps out the top 3 viable commercial applications for this technology. We're going to evaluate each one to help you match the exact solution to the sector you operate in. Achieving a measurable ROI depends on aligning your specific operational pain point with the correct architectural trade-off. For enterprise and federal CISOs, the most urgent mandate is stopping lateral movement across the network to satisfy strict zero-trust standards laid out by the DoD and NIST. This comparison matrix highlights the input required to solve this. On the right, to deploy PTCP Shield, you feed it pattern-of-life telemetry so the system can learn the normal, stable shape of your daily network operations. When an attacker attempts to exploit a route leak or misuse stolen credentials, the network's geometry physically stretches. Shield detects this specific geometry of compromise long before the actual breach triggers a standard alert. The system automatically responds by executing a strict geometric cut. It completely severs the deformed attack pathway, leaving the rest of your business operations untouched. The integration trade-off is that Shield operates as a network overlay. You still need to run your legacy SOC tools in parallel to catch standard, non-moving malware on individual endpoints. This setup is engineered specifically for defense contractors, federal agencies, and large telecom operators. Because cybersecurity budgets are heavily funded and compliance-driven, Shield offers the fastest, most reliable path to near-term revenue. For CISOs, it replaces perimeter guessing with the mathematical certainty of exactly where an attacker is moving. Shift your focus to AI infrastructure. When network congestion leaves thousands of expensive GPUs sitting idle waiting for data, routing becomes a board-level financial drain. Classical routing protocols simply break down under the massive synchronized data loads required by modern AI clusters, creating severe traffic collisions and latency spikes. Look at this updated matrix. PTCP Fabric attacks this by using risk-aware geodesic routing. By calculating future link states, the right side actually highlights potential bottlenecks in red before the traffic arrives. Notice how the active data streams proactively curve around those high-risk failure zones, completely avoiding the congestion. The outcome is minimized tail latency, highly stable network routes, and GPU clusters that actually run at peak utilization. To realize this ROI, you have to commit to deep engineering integration at the SDN, segment routing, or Kubernetes service mesh layers. It is not a plug-and-play installation. This specific engineering trade-off targets hyperscalers and AI data center operators who are desperate to reclaim network energy efficiency. PTCP Fabric is the definitive choice for architects who need to translate mathematical routing predictions into millions of dollars of reclaimed compute. Finally, we move to the absolute highest stakes environments: hospitals, critical infrastructure, and industrial control systems. In these facilities, an automated IT security shutdown can be deadlier than the hacker. You cannot accidentally turn off a ventilator or derail a factory floor just to isolate a computer virus. This 3D matrix shows the complex input required for PTCP Guardian. You deploy passive telemetry to build a live, multi-scale digital twin, precisely mapping the vertical dependencies between your IT network and your physical OT devices. When an anomaly hits the IT layer, Guardian enforces a safe envelope containment. It throws a protective barrier around the specific dependency line, limiting the blast radius of the threat without severing the connection to the physical device. This process relies heavily on TNQG's reconstruction discipline to generate the rigorous, auditable diagnostics required by FDA and HHS regulations. The massive trade-off here is setup time. Because of the required compliance mapping and physical dependency checks, this is by far the most difficult vertical to deploy. Hospital systems and utility operators, large pharmaceutical labs, and smart manufacturing facilities are the perfect fit for this. Guardian secures critical sites where downtime isn't just a financial loss, but a threat to life safety, effectively isolating cyber risks without disrupting the underlying clinical or industrial workflows. Adopting PTCP and TNQG technology is a deliberate architectural shift. It is a highly specialized tool, not a generic software patch. This matrix plots adoption friction against ROI speed. PTCP Shield brings fast ROI at moderate complexity for security budgets. PTCP Fabric demands complex SDN integration, but GPU efficiency guarantees data center profit. PTCP Guardian requires maximum complexity to protect physical safety in regulated environments. If you are a defense or federal leader looking to instantly kill lateral movement in your network, invest in Shield. If you are a cloud architect bleeding money on GPU latency and dropped packets, commit the engineering resources to Fabric. And if you are an operations director managing life-critical hospital wards or active factory floors, you must undertake the rigorous mapping required for Guardian. Relying on traditional, static, packet-level security monitoring is now mathematically insufficient for surviving the cascading scale of modern, systemic network failures. The true competitive advantage now belongs to the enterprise that clearly maps, understands, and actively controls the geometry of its infrastructure.